Today's topic is interior point of a set, right? That is the interior point of a subset of real number. To define interior point, we first consider a subset S of R. Okay, this is the set of real number, and we consider or we let a point X which is belongs to the subset S. Okay. Now X is said to be the interior point of S if there exists, that is we write X belongs to S is said to be interior point of S which is a subset of R if there exists a neighborhood n of X such that X belongs to n of X. It is obvious the point must be belongs to the neighborhood of X and which totally contained in S, and this is a subset of R. Okay, and in this case X is said to be the interior point of S. And now if we form another set by getting all of its interior point, then this set is said to be interior of S. Okay, so we write the set of all interior point of S is said to be interior of S, and it is denoted by, generally it is denoted by S0, or it is denoted by Si, or it is denoted by int of S. Okay, there are three different notation of interior of S, and the definition of interior point may be defined as, we write X belongs to S is said to be an interior point of S if there exists an open interval AB such that X belongs to AB which is totally lies in S which is a subset of R. This definition is also the definition of interior point, because we know that any open interval AB is neighborhood of each of its point. Okay, here we write, since open interval AB is a neighborhood of each of its point, each of its points. Okay, now we give some important example of interior point. If we have to find the interior of a finite set, okay, let a set A which is finite, that is contains finite number of points, let x1 x2 to xn, this finite number of points, this is a finite set, and we have to find the interior of it. This is obviously fine, because we know that finite set has no interior point. Why no interior point? If we try to find out a neighborhood of any point, then we cannot get a neighborhood of any point xi which is totally contained in the set, because we know that any neighborhood of a point which is a subset of R contains infinite number of points. Okay, so here we give a logic, since any neighborhood of Xi contains infinite point, so there does not exist n of Xi subset of A. So this set has no interior point. So interior of A, that is A0, this is equal to 5. If we consider a set like this 1 half, 1/3 to 1 by n and so on. Okay, this set also has A interior, this is equal to 5, because the set is look like this is 0, this is 1, this is half, this is 1/3, this is 1/4 and so on. And it is clear that between every 2 points there be a gap. So if we want to find out a neighborhood or draw a neighborhood like this, then this neighborhood is not lies totally in A. Okay, because only 1 point, 1/3 belongs to this, and the other point here and here, left side and right side, this is not in this set. So this set also have no interior point. So A interior, this is equal to 5. If we consider A as an open interval, let this is PQ. Okay, and clearly A interior, this is also PQ. That is A interior, this is equal to A, because we know that every point of the open interval is an interior point, because we know that in any open interval is a neighborhood of each of its point. Okay, so every point of this set is an interior point, so A interior, this is equal to A. But if we consider A, this is equal to closed interval PQ. Okay, and in this case A interior must be open interval PQ. Open interval PQ, because here P and Q are not interior point, otherwise all the other points are interior point. If we take the set of real number, total real number, then it is clear that interior of real set is also the real set. Okay, and if we take A, this is equal to 5, this is the null set, and since the null set have no point, so interior of null set is also 5. If we take A, this is equal to Q, this is the set of rational. Okay, and we know that between any two rational there must be infinite number of irrational. So if we find out a neighborhood of any point of Q, then this neighborhood not totally lies in Q. So we write that A interior, that is Q interior, this is equal to also 5. That is Q have no interior point, right? And so these are the very important example about interior point, and we say the definition of interior point in different way, and this is the definition of interior of a set. Okay, and this is the today's discussion, and this is the discussion about interior point. Thank you for watching.